Hello. Today we're going to give you a quick review of working with rational inequalities. Here we have an example as given. If we were going to look at this as is, we would have the left side of the equation, which would be a rational function with vertical asymptotes and some zeros. And then we'd have the right side of the function, which say is less than or equal to 2. That'd just be the horizontal line y equal 2. And we'd be looking at all the points of one graph underneath the other. It's a lot easier to compare and try to set to 0 first. That way we're considering the x-axis rather than some horizontal line above the x-axis. 0 is a cutoff between positives and negatives. It's just going to make it a lot more efficient. So first thing I'm going to do is subtract 2 from both sides. In order to find critical values, I'm going to need a common denominator. So I'm going to take, in this case, negative 2 over 1. My common denominator between these two sides is the x minus 4. So I'm going to take the top by x minus 4 and the bottom by x minus 4. That's going to allow us to get x minus 4 as a denominator. I am then going to distribute the negative 2 through. I'm going to think of that as plus a negative 2, and I'm going to distribute that through to make that new numerator negative 2x plus 8. Be very careful there. Common denominator is there. So my next step then is to add those numerators, keep the denominator the same. So to do that, I'm just going to combine like terms. 7x and negative 2x is 5x. Negative 11 and 8 is negative 3. So I have my new rational function, which I'm then going to factor so I can find my critical values. So I factor numerator. When I factor numerator and set each one equal to 0, I get critical values of x equal 1/2 and x equal negative 3. Those would be x-intercepts. If I had a common factor, one of them would be a whole, and that'd be a domain restriction. But in this case, we don't have a whole. We have a vertical asymptote at x equal 4, and that gives me a domain restriction, which is a critical value because I don't want that to be part of my final answer. So I'm very careful to exclude that value. Okay, so the next thing is I put each of those values on the number line. 4, I have 1/2, and I have negative 3. My two x-intercepts. I have closed circles there because I have less than or equal to 0. The equal to implies that I can equal 0 or have a value of 0. So therefore I want to include those values as closed circles. They're going to be part of my answer. On the other hand, at x equal 4, I have a domain restriction. So I'm going to have a vertical asymptote there. Imagine a vertical asymptote through this graph right there. I don't want to include that in my solution. Okay. The next thing I'm going to do then is I'm going to find critical values at each, I'm going to find test values in each of these regions. So over here, I'm going to choose negative 4. In this region, I'm going to choose 0. In this region, I'm just going to choose 1. And over here, I'm going to choose 5. I have to have one in each of these values that I split up on the number line. I'm then going to basically create a little fraction, and I have 2 factors in the numerator and 1 in the denominator. I'm going to fill in negative 4 into that first quantity. Negative 4 times 2 is negative 8 minus 1 is negative 9, so it's negative. Negative 4 plus 3 is a negative value. Negative 4 minus 4 is a negative value. Then I'm going to think negative times a negative divided by a negative is going to be a negative result for this region. Okay, I'm going to repeat that in this region. I'm going to put in 0. 0 minus 1 would be negative. 0 plus 3 would be positive. 0 minus 4 would be negative. Negative times a positive divided by a negative would be a positive result. So this section has a positive. Okay, and unless the curve bounces here, typically you're going to see these oscillating signs. And then finally I'm going, oh, excuse me, not finally, I still have two more sections. I'm going to fill in, oh really, it's finally I get to 1. I'm going to fill that value in and I get a positive value here. I get a positive value when I add it to 3. I get a negative value, so that area, as expected, is going to be negative. Okay, and then finally in this last section, finally I get to 5. I fill that 5 in and I get a positive number in the first quantity. I get a positive number in the second quantity. I get a positive number in the denominator, and that negative or positive times positive divided by positive is a positive result. Imagine that. Okay, so I'm looking for less than or equal to 0, which is negative or 0. Okay, well it's 0 at right here at these values. So those are going to be included. It's negative right here. So everything in that region is included. It's positive in here, so I'm going to rule it out. It's negative in here. I don't want to include that, so I'm going to make sure it's an open circle. And then it's positive in here, so I'm going to rule it out. So ultimately, my answer is going to be this region to the left, which starts at negative infinity and goes to negative 3. We want to include the negative 3. So I put brackets. The second region starts at 1/2 and goes to positive 4, but I don't want 4 included, so I'm going to put parentheses. And that is it, ladies and gentlemen, in less than 7